Hello everyone, welcome to today's lecture. In this lecture, we are going to learn about input-output instructions. So, in a computer architecture, input-output devices act as a interface between the machine and the user. So, suppose I want to find some information from Google. At that time, I am using the keyboard as my input devices, and then after some results will be shown to my monitor. At that time, or my monitor is the output devices. So the input and output devices are the interface for the machine and the user, and the instruction and data stored in memory must come from some input device. The results are displayed to the user through some output devices. Suppose I am writing some content on Word file. At that time, I am using the keyboard as the input devices, and when I print out the document through the printer, at that time the printer will be the output device. So the input-output terminal sends and receives the information. So for any kinds of sending the information or receiving the information will be done through the input-output devices. The amounts of information transfer will always have 8 bits of alphanumeric code. While here 8 bits, because in our previous lecture we have learned that what is the input and output registers. So the size of the input and output register is 8 bits. So that is why we can transfer the 8 bits of an alphanumeric code. When we are typing from keyboard, from that when we'll get the output from our printer, so that complete input output configuration is shown in this figure. So the first of all, we are typing something from our keyboard. Suppose we are writing the content on the Word file. So here we are typing from keyboard. So this is our input device. Now there is a data transmitter interface for the input. So at that time the data will go through this transmitter interface, and then the data is stored into the input register. Now we already know when we are getting some input from input devices, at that time the data will be stored into the input register. From input register we are transferring the data to the accumulator, because accumulator holds the data for short amount of time, and from the accumulator we are transferring data. Now our data is stored onto the accumulator. Okay, now after some time I want to print that information that I have written in the Word file. So at that time the data will be transferred from accumulator to the output register. Now the output register sends this data to the receiver interface. Same as input transmitter interface, there is one output receiver interface, so the data will be transferred there, and from that the data will be sent to the output device. Here the printer is the output device, and we'll get our information from the printer. So this is the complete flow diagram, that how our input output configuration will be work. So this is the explanation that I already told by using this diagram. Now next is how actually the internal processes work. With this diagram we have seen that we have seen the complete flow diagram, but what is actually the internal process? So here we already know that our input register is a 8-bit. So with that input register there is 1-bit flag is associated, and that flag is called FGI. FGI means a flag of input. So here with the input register there is one FGI flag is associated. The flag bit is set to 1 initially when the information of the INP are accepted by the computer. It means initially the flag value is equals to 1. So what is the meaning of a flag FGI equals to 1? So when our input register contains any character in it, at that time the value of the flag will be 1. But when we'll transfer this information or that character to the accumulator or the output register, at that time the value of the input register become null, at that time the value of flag become 0. So we can easily remember that when input register contains any characters, at that time value will be 1, and if it is not contain any information, at that time the flag value become 0. So as long as FGI is 1, the information in the INPR cannot be changed by further key inputs. Computer checks FGI flag. If it is 1, then it transfers the information from input register to the accumulator and then clear the flag to the 0. So when the flag value is equals to 1, it means there is some information stored into input register. So the data of input register will be transferred to the accumulator, and after that will change the value of FGI flag to 0. Once the flag is cleared, new information from the keyboard can be transferred to the input register. So when our flag will be 0, so at that time new information from keyboard can be transferred to the input register. Same as the input register, there is one FGO flag is associated with the output register. So here is the output register, and with that FGO flag is associated, and initially the FGO value is equals to 1. Now here the 1 means when the FGO is equals to 1, at that time output register is empty, and when FGO value is equals to 0, at that time output register contains character. So it is totally reversible to the input register. In the input register, when the FGI is equals to 1, it means it contains characters, while in the output register, when FGI is equals to 1, it means it does not contain any character. Okay, so it is totally the reverse from FGI flag. Initially FGI is set to 1. When it is set, it indicates output register is empty. Computer checks FGO flag before any transfer of information from accumulator to output register. So here whenever data is stored to the accumulator, at that time first it checks the FGO flag. If the FGO flag is 1, at that time only the data of accumulator is transferred to the output register, because when flag equals to 1, at that time the value of the output register will be null. But when the FGO flag is 0, it means that it contains some information in the output register. So the data of accumulator cannot be transferred to the output register. So if FGO equals to 1, computer transfer the information from accumulator to the output register, and then FGO is cleared to 0. When FGO equals to 0, the output device such as printer accepts the character from the output register and print it. During the process FGO equals to 0 and it is set to 1, process is completed. Here when we'll transfer data from accumulator to the output register, at that time flag value equals to 1. After the transmission, we'll change the flag value from 1 to 0. After that, the data of the output register is transferred to the restore interface, and then after to the printer, and then the data will be printed out. So this is how the complete process works. So let's understand this with the help of the language of RTL. So first, initially what we are doing, we are getting the information from input register. Here first of all we have data into the input register, and from that we are transferring data to the accumulator. So here first of all the data of the input register will be transferred to the accumulator. Now the question here is, the size of the input register is 8-bit and the size of the accumulator will be 16-bit. So how we can transfer? So we can transfer the data of input register to the accumulator by the MSE bit. So from 0 to 7, the data of the input register will be transferred to the accumulator. After transmission of data, we have to change the flag value. Initially the flag value of FGI is equals to 1. After transmission, we need to convert the flag value from 1 to 0. So that is why the second statement is will transfer 0 to the FGI. So here now value of FGI become 0. Then after we'll transfer the data from accumulator to the output register. So here we'll transfer data from accumulator to the output register. So here the 7 bits of accumulator will be transferred to the output register. Initially the FGO flag will be 1, but after transmission of data we need to change the FGO flag from 1 to 0. So here FGO arrow and 0. So these are the two statements. Then after we need to check that if FGI equals to 1, here in the information now our data will move to the output register. But here the input register is empty. So at that time we can accept the data from next instruction also. So here first we'll check that if FJ equal 1, yes, then we are incrementing the program counter by 1. Same as if FJ equal 1, then we'll increment the program counter by 1. After that there are two different flags, interrupt enable on and interrupt enable off. So at that time we'll first set the value of interrupt on to 1 and then we'll set the value of interrupt off to 0. But that interrupt concept that we'll learn in our later videos. So that is all about the input output instruction, or how our data will be transferred from our input devices to the output devices with the help of input and output register and the accumulator. So that's it. Thank you so much.